Hello. Like children at a party, when one starts screaming, they all do. Is it screaming children? Is it an action potential? Scientists can't tell. Both work essentially in the same way. An impulse is sent to one neuron, and then once that impulse reaches threshold excitability, it then passes on to the next neuron, and so on and so forth. The neurons firing look a little bit like this. The issues begin when the children get too excited. This leads to hypersynchronization, which just means that one neuron gets very excited, then all the surrounding neurons see that one, and then all the children freak out. Nature's natural defense to calm the monsters is, of course, parents. So to calm the raging neurons, we have negative ions, such as negative chloride ions, that are in place to prevent hyperexcitability. Once the neuron becomes too excited, it can cause several side effects. The primary symptom of an epileptic attack is a seizure, and just to be clear, it's not just one seizure happening, it's several seizures over a period of time, and these seizures can be categorized into 3 different types: focal onset, generalized onset, and unknown onset. Now, when categorizing these, the doctors will generally look at where the seizure begins, if there is movement, and whether or not the person involved is actually aware. The mechanisms behind the seizures are essentially balanced on excitatory transmissions and inhibitory transmissions. There are other neurotransmitters involved in brain activity, however the main one involved in epilepsy is glutamate. Excitatory transmissions are controlled by glutamate. The inhibitory transmissions are controlled by GABA or gamma aminobutyric acid transmissions. We have several treatments in place to help epileptic patients. However, 20 to 30% of those patients are actually not responsive to that treatment. Therefore, we need to come up with something new and more inventive to deal with patients that are actually more unique, like children, whose physiology hasn't quite caught up to the medicine that we have at the moment. The initial idea is to attack the problem at the source. So we are dealing with energy. If we control that energy, we can control the problem. They started investigating the effectiveness of a ketogenic diet that is essentially a high-fat, low-carbohydrate diet. It can actually help reduce seizures in patients that are treatment resistant. The ketogenic diet is thought to work by changing the way cells produce energy, and for reasons that are not fully understood, this shift in energy production calms the excitability within epileptic brains. Substrates such as ketone bodies have been found to exert neuroprotective effects. We wondered if we could exploit this principle to find different drugs that help decrease seizure activity. Since cellular metabolism has been linked to the underlying cause of epilepsy, it is possible that returning the mitochondrial-mediated energy to resting potential could possibly improve symptoms of epilepsy. Crash and Rowe made a surprising discovery. They said, "We tested a drug currently used for cancer treatment, it's called Xylinza, and found that it reduced average daily seizures in zebrafish and mouse models for 60%. Xylinza is a small molecule that promotes chaperone-assisted folding in GABA-induced chloride currents. Now those chloride currents are incredibly important, as I stated before, in inhibiting the cell. The findings suggest that VCP inhibition without stress induction, together with folding enhancements, provides a new strategy to restore proteostasis to misfolding-prone GABA receptors, and therefore a potential remedy to idiopathic epilepsy. In epilepsy, the excitatory cells are constantly firing without an inhibitor to stop them. This would suggest that there is something wrong with that inhibitor. Therefore, there is something wrong with the GABA receptor. What this medicine could potentially do is restore that GABA receptor to its original function, and therefore allow the cells to begin inhibiting the excitatory cells. In conclusion, the accessibility of this medicine can improve the patient's quality of life.